Hello, my name is Archie, and today I'll be explaining to you how to solve a problem about optimization. Optimization problems can help us in our daily life, and they are fairly simple to solve too. From calculating the maximum material needed for a box to finding the dimensions to minimize our cost, optimization problems can be very helpful. The problem we'll be solving today is about a metal can in the shape of a right cylinder that must hold a volume of 8 pi. Its material for the top and bottom costs twice as much as the side, and we need to figure out the dimensions of the cylinder that will give us our minimum cost. Firstly, let's look at our diagram, which shows the height and radius. The formula for volume for a cylinder is volume equals pi r squared h, and we can assign variables to the height and radius. So h equals height and r equals radius. These variables can be all real numbers as long as they are greater than 0, and this is our restriction. We know that 8 pi is our volume, so we can set that equal to the volume formula from the previous side, which is also our constraint. Our dependent variable is going to be our cost, since it has to be minimized. We need to write out the cost using the surface area formula since we're looking at the outside of the cylinder. In our case, surface area of the cylinder can be found by using the area of a circle, which is pi r squared, multiplied by 4 because there are two circles, top and bottom, and their cost is twice the side. This results in the first term of the cost formula, which is 4 pi r squared. We also need to find the surface area of the lateral side, which will be 2 pi r h. Now, we can solve for h using the formula we had in the first slide with the volume. This will give us h equals 8 over r squared. We can substitute this value into the cost formula, which will give us cost equals 4 pi r squared plus 16 pi divided by r. Now, to find for the minimum cost and dimensions, we will need to find the first derivative of c, which gives us c prime equals 8 pi r minus 16 pi over r squared. Using this, we can set c prime equal to 0 and solve for r. Therefore, we will get r equals cube root 2, also known as 1.259. We can substitute r into the formula we had for h from the very beginning, which was actually h equals 8 over r squared, and solve for h. Once we do so, we can get that h will equal 5.039. To check if the extrema satisfies the conditions we set in the beginning, we can do the second derivative of c, and as you can see, it will always be greater than 0, which is what we want. This is because r will always be greater than 0, and so the second derivative of c will also always be greater than 0. Lastly, to find the minimum cost, we can do cost minus minimum cost and sub in r and h into the cost formula. This gives us a final value of $59.84. Therefore, the minimum cost for this cylinder will be $59.84 when the dimensions are at a height of 5.039 centimeters and a radius of 1.259. Thank you for watching. I hope you enjoyed the video.